Welcome to this topic on communications for the Airbus A320 family. Again, if you've been through other GenFams, communications is the same types. So I'll just give you a quick rundown. This is just going to be the overview of the communication systems that exist and kind of go over some of the units and some of the computerized systems that we have that are making sure that we have the radio frequencies in order for us to have speech, with audio communications, as well as any navigation, to operate also the radio navigations. So just as far as communication, what kind of communication are we talking about between, what two entities? We're talking about on the aircraft itself. So we are talking about the crew members, the flight crew members being able to communicate with the ground. So that would be any ground service personnel, maintenance, the ground stations, any types of communication there. We have to make sure that there's no interference with that communication. And of course, then you have communication between aircrafts. So you have aircraft to aircraft, as well as within the aircraft you have to passengers, right? So there's the the addressing and reporting system that we have in the cabin. So that's part of it. And then that's pretty much it as far as the communications that go on there. There's a couple of different systems that are managing or centralizing the frequency and also controlling and monitoring them. So just to mention a few, we got an audio management system, and there's panels. You have the audio audio control panel, as well as you have a radio management panel, which basically centralizes the frequency control for the two types of frequency systems. Namely, in general here, we got the high frequency system as well as the very high frequency system. So keep that in mind, because you may see that on the test as far as, what are the two kinds of systems that we have as far as frequency. That would be high frequency and very high frequency. And of course, you've got your built-in test equipment for high frequency. And what are you going to see as far as warnings and the data that you might see on a leg report. Those are things also that we're going to be looking at. But just to give you an idea of what kinds of listings that you would have on display, that may be where there's a failure. And I'll get into some of the the meanings of the acronyms if I mention them right now and you don't know what I'm talking about. But what we have for sure are the decoder encoder units. There's two types. There's type A and type B. And so if that's displayed on the CIDS menu, on the multipurpose control and display unit, if you have that, then that's a possibility if there's something wrong with that. And then you got cabin assignment modules. Something could go wrong there. These are just kind of checking to make sure that these units are functioning properly. You also have your your attendant panels, your buses, and your directors as well. So kind of gives you an idea, just roughly, with what things could possibly go wrong. What can you see on there? It's going to be testing also your radio management panel, your panels, to make sure those are operating, at peak level. So also the aircraft, incidentally, has static dischargers, because if you recall from one of the other topics and the other instructional videos, I actually mentioned about static electricity and how much that can affect the communications, radio communications. So it gets pretty interesting, because from a scientific standpoint, it's pretty fascinating. But here, we don't want to have static, electricity, hitting the aircraft and interfering with communications. Communications is extremely important to the safety of the aircraft and everybody on board, including ground people, because you don't want to have an aircraft getting wrong communication, either data communication or speech, that causes them to have a wrong navigation and crash, have a crash landing, or they think they're supposed to be landing in a certain place, turn out to be maybe a ground station with there's people around, ground personnel. So certainly helping keeping the plane safe could save your life, or just definitely protect the people down on the ground. Okay, so definitely there's the static dischargers that are installed on the aircraft in order to discharge that static electricity away from the aircraft. All right, so that gives you a good idea, at least kind of a helicopter's view of the different things that we're talking about here with as far as communication between different parties, and also the radio transmission, the radio communications for navigation, etc., that are important to not be disrupted or interfered with. All right. Okay, so let's kind of start with some components that we can mention. Certainly, there's a lot of different things here, but just in general, remember I mentioned about the high frequency system. So when we're talking about communication, we're talking about, it could be speech through interphone. So we got a phone, telephone, actual interphone system of some sort. So we have that. That's for speech. Okay, so you do have your interphone system, and that's for cockpit to be able to communicate to the ground crew. And then, of course, you have your flight crew interphone. So that's the flight crew being able to communicate with each other, and then the cabin and the service interphone. So obviously being able to communicate with passengers, important information from the captain, or just simply, any communication that needs to be done on the public address. Okay, now audio integrating system, you do have an AIS, your audio integrating system, and this is just going to manage all the audio signals that are coming, being involved here with, your push to talk, your microphone inputs, things like that. Okay, you also have a cockpit voice recorder. Okay, just like in any aircraft, there's a recorder, and so in the event of an accident, that recorder is able to capture, the recordings or the conversations, of the flight crew or whatever was going on at that moment. Whatever can be recorded about what was going on right before, an accident or an incident. And then you have your ACARS management unit. That's your aircraft cabin addressing and reporting system. And again, that's just a management of the data that comes in from the crew, and that's transmitted to the ground. So that's what that is there for. Now, the two types of systems or frequency systems, remember I mentioned earlier, was your frequency and your high frequency and your very high frequency system. So those are your two frequency systems. Now, when do you use high frequency, and when is high frequency used versus very high frequency? I mean, it sounds so ambiguous too, right? I mean, certainly we can do the science of it, but you're probably not too interested in that. But bottom line is, your high frequency system is used for long range voice communications. And then your very high frequency, your more short waves, are actually used for short range voice communications. Okay, so high frequencies for long range, and very high frequency is for short range. Okay, and each of them have transceivers. Okay, and other. So we'll get into a little bit more detail a little further down, but there's an antenna, one of them has a coupler, okay, but you definitely have the transceivers in both situations there. Okay. Your RMP, which is your radio management panel, that's basically a centralized place for frequency control of the two frequency systems I just said. Okay, and you may see something as on a test, okay? You may see this on a test. The radio management panel, the RMP that I just said, can actually serve as a backup for your flight management and guidance computer. Okay, remember, radio management panel's in charge of, not just speech, but also helping with navigation. So being able to help with managing the communications frequency control for radio navigation. Okay, so that would be for your VOR, your DME, ILS, okay, your ADF. Okay, so you get into navigations class, and you'll know what I'm talking about. Okay, I'm not gonna name them all here, but that's if you know those are just acronyms or abbreviations for these different navigation components. Okay, so what do you expect to see on the radio management panel? Okay, well, what you're gonna see is they're gonna see a lot of like buttons. Okay, the call buttons are there. You've got your VOR, your ILS, your basically your navigation buttons, ADF, your BFO, but you got your call buttons. And you may see this on the test, okay, but if you see 3 green bars, when you punch a button and you push on it, then you're going to have 3 green bars, and that just means that that's the one that was selected. Okay, that's what that indicates. Now on the front of the radio management panel, you're going to see an on-off switch. And that's just to set the panel on, or off. You also have, on that front face, you have 2 panels to it. There's 2 display panels, if you will. So you have those. And then there's an active frequency and a standby. So you got your active frequency display, okay, for output by the management panel. Okay, so what's going out. And then you also have a standby course display. And those are just your preset frequencies on that window, or that, that sub panel, if you will. Okay, you do have a selector indicator light. That's going to be an amber, and that's just to indicate the interactions between the different RMPs. So SEL, here's, the indicator light is for that purpose. You have an AM push button switch for high frequency. Just kind of be aware that RMPs can have a little bit of different configurations, so don't expect, and you probably wouldn't anyway, but I tell your AMM for that specific group you're working on, but not every RMP is going to be exactly, with everything the way, one might have all these different ones on here, but there might be maybe one missing on another. Just know that that's just a configuration difference. You've got also your nav selection feedback. Okay, and that one in particular has a guard on it, on the switch, and it's just to protect it. Okay, and then the audio control panel, the ACP, that's just there to display mostly. I mean, that's really what it's for, and it's displaying the calls. Okay, ground crew calls, or the calls from the cabin attendants. All right. And I'm not going to get to how many buttons here, how many buttons there. I'm not going to quiz you on that. Just know that there could be 7 potential rectangular push button switches for the different channels. Okay, and then you have your rad selector switch for your radio and your flight interphone functions. So that's there. You have your voice, and of course then you have a reset. Okay, so that's when you want to shut off, you're done with the call, that you can just hit that reset button and just resets everything. All right, your audio management system, this is going to be for all the radio communication and also your navs. Okay, your radio navigation facilities on the aircraft. You have different components that are involved with the audio management system. You got panels, a head jacks, headset jack. You've got also a jack for the ground crew. There's the speaker potentiometers. You got 2 hand microphone receptacles, one for captain and one for first officer. Okay. All right. So, and of course, you got a unit for this. It's just again it's the unit to centralize all of the radio activity. Okay. And of course, like all electronics, it's located in the avionics compartment. Okay, so just follow your AMM. I don't want to say exactly where it's located because I don't want to confuse anything at all. It should be the same place, but you just follow what it says. It's your MRO, and obviously at the AMM in the AMM. Okay, so that's what the audio management panel's for. Remember I said I was going to come back to talking a little bit about the high frequency system and the very high frequency system and the components that are involved with those. It's pretty simple. You've got an antenna, your transceiver. Now in the high frequency system you do have a coupler. Okay, so you've got, in your system you've got your transceivers, couplers, and antenna. Okay, and depending on, again, the specific aircraft or configuration, as far as how many, I don't want to go into quantity, just know that those components make up the HF system. Okay. You also have there's two different architecture with this. You have one with a single HFRT unit, and this with a dual. Okay, so you have those, and your interface, of course, is going to be with your RMP, okay, your radio management panels, and also with your SDACs. All right, and so just know that when on the high frequency system, you do have the architecture with single HFRT units and the ones with dual. Okay, and diagrams can help you to see a little bit better with kind of the chart, the flow, kind of where communication is going. Well, I'm talking about electronically to the different couplers and the different units, like your AMU and your SDAC. Okay, and of course you have your standard built-in test equipment. That's going to show in your ground report, last leg report. Your menu modes are going to show where you can, select if you want to see, any faults at the previous legs report or last leg, troubleshooting data, things like that. Okay, and very high frequency system. Okay, that was all for just the high frequency system. And remember, high frequency for system is for what? Okay, it's for long range communications. Okay, so now on very high frequency, the very high frequency system, this one is for short range communications, and that's going to be voice communications between aircraft in flight. So one aircraft, flight crew from one aircraft can talk to another crew from another aircraft that's in flight, and also being able to have the aircraft communicate in flight or on the ground, and to ground stations. Okay, so that's what that very high frequency system is for. Okay, now you have two VHF systems. They are completely independent of one another. Just be aware of the number that typically you're going to have two. Again, it's redundant system. In some you may have another, but I'm just sharing with you that you have at least the two identical very high frequency systems. Here on the controls for this particular system, you do have a transceiver and also a blade antenna, and it's interfacing obviously with the radio management panels, and they're just being centralized there, with all of that. You do have one of the systems that's associated with the ACARS. I mentioned that earlier. That's your aircraft communication addressing and reporting system. Okay, so it's associated with that and connected. Okay. You probably already know about the different stories, and these are real, obviously. When aircraft have gotten wrong information. So, the radio navigation, for example, is so important. The communication that goes on from the aircraft to ground station, etc. Back to aircraft, in order for the plane to have that proper navigation and being able to land safely. So just keep in mind just how important all of this is, and you've been around for a while to know how important all of this really is. Okay, with communications. All right, and again, some block diagrams can help you get an orientation of kind of what goes to what, kind of like we've had before. Okay, any faults are going to be recorded, of course. So the computers are constantly monitoring these things and testing for faults. Okay, let's just mention a little bit. I know we talked about static dischargers. Static dischargers. We could talk a little bit on physics, but I don't know how interested you would be in that, but I find it fascinating personally. But it's okay. Just know that you've got 41 static dischargers, that are located, on the exterior of the aircraft, because it's just any kind of appendage, anything out there. Extended, is the first to get hit. If we have lightning strike, for example, then there has to be a way to, on that first, contact, that those dischargers are there, that they're installed in those locations, and that's where they are at. So just be aware that there are those static dischargers throughout the around the aircraft, so throughout that, and they have to, be at a certain operational, level. They have to be at least 80% in correct operation in order to do its job. So anyway, just to make sure that they're seated properly, when they're installed, obviously that they're not damaged in any way. So again, they could be in different places. They might be there's on the wings and the ailerons. Also the elevators, your vertical stab, the rudder, your stabilizer tips. Okay, so when I'm saying the extremities and the outside of around the aircraft. So, again, that's the whole idea here. Because if, lightning does exist and planes do fly up there. And, let's say there's lightning, then what's going to take the hit, essentially? It's going to be the static dischargers. Those are going to be hit. So that's what we want. We don't want to have it go to the aircraft itself. Okay, so that's on what we have with static dischargers. There are, quite a bit of them, like 40 or so, that are strategically placed on the aircraft. Now, on the cockpit voice recorder, okay, you have that. Remember I mentioned it has, it's just there as a recording, kind of the last conversations and discussions or whatever that's going on before an aircraft, would go down, or at least if it did have an accident, then it's able to, the investigators are able to take that and at least listen to and get as much information as possible of what happened before the crash. Okay, so that recorder is there to record, those conversations, and it can do that in flight or on the ground. Okay, so, and there has to be at least one engine running. At least one engine running for it to, to have that be in operation, or up to 5 minutes after the last engine has shut down. Okay, but again, follow the manual on that as far as where it is, testing it and whatnot. But that's what its capability is. Okay, and typically it can store around like 2 hours of recording. Just giving you an idea. Okay. All right. So then also we have, of course, you've got a remote microphone installed in the bottom of the overhead. Okay, so you got a microphone, and that's part of the installation there for capturing, right? And of course the amplifier. All right. So another important part of this communication is to ground maintenance. And so you guys are probably familiar, or I know you're familiar with this, but we have a ground crew call system, right? So the cockpit wants to communicate with somebody on the ground, in particular the maintenance guy. So, cockpit, obviously it's in the cockpit, is going to press the MECH push button on the overhead. Okay, and that will notify. It'll be a horn that sounds, as long as it's pressed in, the horn will continue sounding. Excuse me. And then the call light is going to show up. It's going to light up. Okay, and then once he's done whatever, he can just reset that button and the light's going to go off. Okay, and just another time that you're going to hear the horn is going to be a, you know, APU's fire, there's fire on the ground, or APU fire on ground. Excuse me. The aiders on BAT, okay, on battery, on ground with engine shut down, and blowers low flow. Then that horn is going to sound. All right, so then let's say ground mechanics need to reach the cockpit. You know, they can do that. There's a mechanic pushes the cockpit call push button on the external power panel if he wants to reach somebody inside. And of course, it's going to be flashing amber on the ACPs, and there's going to be a buzzer that's heard over the cockpit speakers. So anybody there can listen when the mechanic's trying to reach somebody there. And there's a kind of a diagram, maybe not the best one, but it's a diagram nonetheless, kind of giving you an idea of, you know, the order of the buttons. Okay, so that's like the communication between your mechanic or other ground service personnel and the flight crew. And then you also have, of course, your interphone. So this is within the aircraft, where you have a telephone communication. Not just, you know, in the cabin, you also have the service. So this is also between ground and flight crew. You have an interphone system that's there on the ground between the flight crew, also the cabin, and the ground service personnel. Okay. You have the audio lines from the maintenance interphone jacks that are going to the amplifiers in the CIDS. That's your cabin intercommunication data system directors. Okay, we have two directors, Director 1 and Director 2, and those are the ones where they can fail. So just so you know, when you're doing testing, or you're looking for something on the menu for troubleshooting, etc., you're going to see, that's one of your choices is Director 1, Director 2. If there's a failure, then that's one of the potential things that could show up on that menu. All right. Okay, so with here you've got, again, the CIDS directors. Okay, so amplifiers in both those. And then the system's going to get signals for the operation and the control light from the interface units for the landing gear. So it's going to be it's coming from the landing gear control and interface units. Your CIDS directors, also your service int override push button switch on 15RJ. Okay, so as far as the interphone system goes, you can operate from the cockpit or from the cabin attendant stations, right? So they each have, at those areas, the necessary, signals there that are going to go to the CIDS directors. Okay. All right, so let's talk a little bit, since I mentioned about the cabin intercommunication data system. Just kind of going over some of the functions of the it's otherwise CIDS. Okay, and you have, like I said, this aircraft is, it's the same with the Boeing, but we're on the Airbus. You've got the computer systems there, and they are operating. And so this CIDS is a computer-based system. It's going to be doing everything that I've talked about with other computer systems. It's going to be self-monitoring, it's going to be monitoring, it's going to be testing, and just making sure that things are working properly, are functioning, and trying to detect anything when something's not working properly. So just some of the functions, it's going to be checking the passenger call. You've got anything with a passenger related, so the passenger cabin illumination control, the signs, the passenger address, and also the reading lights for the passengers, the entertainment system, things like that. It also is going to be monitoring the lavatories, because you have smoke detections in those lavatories. So it's going to be checking that as well. You've got your emergency lighting test. Also it's going to be monitoring the escape slide bottle pressure. So it's a lot of different functions the CIDS is doing. Remember, it's just a big, computer there. A lot of different things with the hardware on this, but main thing is it's obviously it has memory there in its module, and being able to you can reprogram it, etc. It's just, again, like a computer, big computer. The scheduled maintenance for it, you don't have to. Now, there's some things that are scheduled for maintenance, and some that aren't. This one doesn't have one necessarily. Do follow the AMM, but in general, it's not absolutely necessary, because it has its own self-check. It's just like some of the other computer systems that I mentioned, even hydraulics and some other things. It has its own built-in, it's kind of checking on itself, and doing a self-test to make sure things are good. So that's probably why. It's like the computers have gotten more sophisticated, where we're not having to do so much of that scheduled maintenance. Okay. So, and of course, if there's anything wrong, the indications and those warnings are gonna show. Okay, so remember I mentioned about the directors. There are two. There's Director 1 and Director 2. Okay, so just like in just about everything on an aircraft, you have redundant systems, and it's no different here with having a second director. So our Director 1 is our primary. Okay, that's our primary, kind of our, kind of the brains, if you will, of the operations with the CIDS, okay, or the Cabin Intercommunication Data System. But you do have a Director 2, so that's Director 1. Director 2 is going to take over if for some reason Director 1 has a significant failure that it's not doing its job. Director 2 is going to take over. Okay, so that's what you have there with the relationship between Director 1 and Director 2. Okay, now just so you kind of get a little bit of familiarity with the directors themselves, and of course they're just a module. I mean, they're just essentially a box, right? But those boxes in the front, okay, kind of in the front, well, yeah, in the front, there's a cassette, actually. There's a module, and it's a replaceable module cassette, and it's in the front face of each of those directors. And what it's doing is it stores the software for the directors. That's all that is. So kind of getting a little bit more detail in the functions of the directors. You've got the interface with the flight deck and the avionics compartment. Okay. Also, it's going to do some test functions, programming functions. It's going to control the CIDS functional units, and also the bus lines. Okay, so giving you an idea with that. If for some reason there's not enough power, then it's going to the director's going to go in an automatic emergency mode. And so basically it's conserving energy as much as it can while still trying to run. So it just reduces its demand on its own when it detects that there's the electrical power that it normally requires drops. All right, so that's what I have to say on the directors. The interfaces, you're going to have interface with the smoke detector control unit. Okay, why? Because remember what I said before, your CIDS, your directors are going to be also checking, the lavatory smoke detections, systems. So obviously it has to interface with the control unit, right, for the smoke detector. So you have that, and also your landing gear control interface units those are being used by the directors to control the no smoking signs. So it's interesting the interface with the other units in other areas, okay, like your smoke detector and your landing gear. So again, that's the reason why with the landing gear is because it's tied to this, controlling the no smoking signs. Okay. Annunciator light test and dim box, that's used to test obviously and dim the CIDS push buttons. Also your cockpit call panel, provides the call buttons for the flight crew. Okay, so those are the different parts that the CIDS is interfacing with. Okay, and the other thing too is going to be the decoder encoder unit, and we have two of these, and there's two types. Okay, there you have your decoder, and it's abbreviated DEU. So if you see DEU, and I'll more than likely on the test, I'm not going to expect everybody to remember this stuff, and plus some of you already know anyway, but decoder encoder, that's what it is. Decoder encoder unit, there's two types. There's type A and type B. And your type A, okay, these are going to be installed along each side of the passenger cabin. And you can have, there's, as far as your PSUs, okay, your passenger service units, you can have about up to 3 of them that are going to be connected to one of those units, okay, one of your DEUs. Okay, so those DEUs are going to be connected to the directors, and the way they're connected, there's two top line twisted pair data buses. Okay, and so the physical form of that is they're twisted along each side of the cabin, and of course they're connected to the DEU. Okay, and as far as interchangeability, I won't make a great statement about it. I'm just going to tell you that the DEUs type A are identical. They're exactly the same, but do follow your AMM as far as any replacement action. Okay. All right. So then you have your DEU mounts, and I'll get into this a little bit, just on a little bit here, but keep in mind about the mounts, because remember I said there's type A and type B on your DEUs, and they each have mounts, but guess what? Those mounts are not exactly the same. You can't use the mounts for a type A on a type B. So let me repeat that. They each have mounts, and you can't use a mount for a type A, DEU on a type B DEU. Okay. All right, so that's what you have, your decoder encoder unit type A. Now, and those are installed, remember, in each of the passenger cabin area. Now, what about the DEU type B? Okay, so these, where you're going to find them, they are actually in the door areas. Okay, so in the door area, that's where you're going to find them. All right, and if for some reason there's nothing installed there, and I'm talking about the DEU type B, then you're going to have mounts with everything that's needed for for installation. Okay, now of the type B, those are identical. The units are identical, and those have coding switches in the mounts, and those are again able to be used to identify a different address for each of the B locations. Okay, so you have that, and those type Bs are connected to the flight attendant stations and also safety equipment. So any safety equipment, that's what those are there for. They're connected to the emergency power supply units. Okay, your slide bottle and door bottle pressure sensors, and your attendant handsets, your area call panels. That's what the type Bs are connected to. Okay, flight attendant stations and safety equipment. So you may see that on a test. With the DEUs type B, what are those connected to? Okay, and that's the answer. And as far as your mounts go for each of those types, they're close together. I mean, in other words, they look sort of alike, but there's the mounts are pins actually, and they're indexing pins. Some of them are outer types, and the other ones are inner. And so that's the difference between those mounts, and that's why I'm saying they look alike, but they're not. So you want to be careful with that. You can't install the type A DEU using, the one for type B. The one for type B uses inner indexing pins. So you can't use inner indexing pins with the type A DEU to install or mount, so, and vice versa. Okay, you can't use type A DEU's outer indexing pins to mount the type B DEU. Okay, and remember I said about the mounts having the address coding switch? So when you're replacing the mount itself, you're going to have to there has to have the correct code set on that new DEU mount. Okay, so kind of just pay attention to your schematic manuals, and of course there's placards throughout the aircraft, as you very well know, and that way you're seeing exactly what needs to have happen there. But that's just additional information as far as those placards go, because you need to follow step for step in the AMM as to how to change that out, and also to set that correct code on for that mount. All right, so that covers the mounts for the DEUs, and they talked about the directors. So let's talk a little bit just about your attendant panels. Okay, so you got your forward and your aft, right? So you have forward attendant panels and your aft attendant panels. And you also have the miscellaneous panel and your water panel. So those are there as well. With your water and miscellaneous, you do have your lav smoke light for your lavatory smoke light. So that if that comes on, that means somehow cigarettes came through. Okay, means obviously it's detecting smoke. It doesn't necessarily have to be from cigarette; it could be from somewhere else underneath the aircraft. But it can be detecting smoke in the lavatory, wherever that source is, whatever that source is. And then of course your EMER light, your emergency light for emergency lighting. And then you have your reset buttons. You also have your SIDS caution light. Your CIDS caution light. If that comes on, then you're going to have, it's going to be indicating a class 1 cabin failure. Okay, that's detected with that CIDS. So, that's why that would come on. And then your aft panel, that's in the aft entrance area on the left side of the aircraft. There's a reset button there, basically canceling if there was a laboratory warning or laboratory smoke warning that came on, and sound is coming from that, and it's cleared. Then, resetting the button's gonna stop that and just call that all off. Okay, so all right. So then, what about we also have a programming and test panel that is actually located on the forward attendant panel. So of the two attendant panels, okay, forward and then the aft, we have on the forward attendant panel or station, we have the programming and test panel. And that's going to be left of the forward attendant panel. So it's going to be at that station, but left of the forward attendant panel. And so it's in that area. And that's behind a hinged access door. So you'll find that located there. There's also a CAM, which is your cabin assignment module, and that's in the front face of that programming and testing panel. Okay, so what does this programming and test panel do? It's going to be looking for faults. That's why it's called a test panel. Okay, it's going to be looking for faults that maybe were stored in the director. Okay, I'm talking about the priority director, your director 1. So if there was anything stored there, then, in that memory, then it's going to be looking for that. It's going to be examining and detail that particular fault data. It's going to be looking at that. And then it's just basically monitoring any, failure status. And any connected systems to the CIDS, it's going to be looking for faults. Okay, so that's what it does. Okay, and then you also, of course, there's an indicating panel. I mean, there's with the attendant indicating panel, this is your AIP, by the way. Attendant indicating panel, there's a pink and a green indicator light, and those are just attention getters. Okay, that's just just know that there may be lights on there. Maybe different colors, but just know there may be lights on there. If they show, that's just, again, just kind of getting the attention of an attendant. Okay, and then what other panels do we have? The other panels that we have are going to be more that we have them in the ceiling. So here we've got left and right center ceiling at the end of the cabin and also in the middle. So in the middle and the end are where we have some call panels there as well. And you know, there's a call, like for example, if there's a call from a laboratory that and that turns on the amber light on that area call panel. It's going to be close to the laboratory where it's coming from. Okay, which makes sense, right? So as far as colors for the area call panel, you're going to have green, could be blue, pink, it could be amber, okay, for a laboratory call. Okay, and then of course your phone. You know, if you looked at the phone itself, there's 9 buttons on it, and it's pretty self-explanatory. I mean, you've got your PA for public address for all, captain. You also have for aft left attendant, aft right attendant, your forward attendant, emergency call, reset, service interphone. So those are the things that you're going to see as, you know, buttons on the actual phone. Okay. So again, just kind of a regular phone. I'm going into detail of that. It's pretty self-explanatory with that. And remember I mentioned about your warnings and your failure data. Okay, so what kinds of things could we have that could go, if something goes wrong, it's going to be indicated. The caution light's going to come on. If we have, obviously, if the priority director fails, that's going to be indicated. So we're going to have a caution light come on for that. Of course, if both of them fail, so we have priority fails, and then we, you know, director 2 kicks in, but then for some reason director 2, maybe there's loss of more electrical power, and it can't even, you know, can't even sustain at the and consume, you know, at a lower level, so that kicks off. Then we're going to have a caution light that's going to come on. If there's no data coming from the SDCU channels, then we're going to have a failure on that, indicating. And you know, all the other ones, when we talk about programming and test panel, if that fails, basically a lot of your main stuff, your panels, your DEUs, your CIDS top bus and your mid bus, if those fail also, that will be indicated. Okay, and remember about the operation on the programming and test panel. You can do, you know, like if there, it needs to be maintenance on the PTP. Okay, maintenance has to be done on the programming and test panel. You could actually do quite a bit with that, just using the menu itself. So here, what do we have? You've got programming, because you can reprogram the programming and test panel. So there's the programming of it. You also have a system test. You also want to be able to tell system status, so you have that option as well. System status is going to let you know if there's any failures at that point in time, if there's any failures that were detected, and if they don't show up on that panel, then that means everything else is working fine. But if they show up there, then obviously something's wrong. Okay, so that's what I have to say about program and test panel. Of course, you have your CFDS, and that's on your multi-purpose, okay, on your MICDO, and you've got your different, again, like I said before, about the failures that could happen to what components. Obviously your DEUs, your directors, your panels, okay, the laboratory smoke detection, very important to make sure that's working properly with detecting smoke in the laboratory, right? Okay, so yeah, that gives you the idea of where these panels are, and then what kinds of things are going to show up there. Okay, because anything could be you know, failing, but these are examples of what can show up on there as a failure. All right. So kind of gives you a pretty good idea of what we have with communications. The cabin and service interphone. But then we also have ground crew. Ground crew needs to be communicating with flight crew, you know, on the ground. And then we also have the two types of frequency systems. It can be your high frequency and your very high frequency. Okay, remember, high frequency system is for long distance voice communications. And then your very high frequency is for short range communications. All right. Okay, so I hope it gives you a pretty good idea of just the communication that we have on this aircraft, as well as the protection of the communications, which are going to be your static dischargers that are located exteriorly about the aircraft, okay, like your vertical stabs and your elevators, etc. Places like that. There are at least 40 of them, just somewhere around that number. Okay, so it gives you an idea with that. So let's go ahead and do some knowledge checks to give you an idea of the types of questions that we can come across here. All right, so what do we have? Let's do a question. Which components of the communications system can serve as backups for the flight management and guidance computers? Okay, is it the RMP and ACP? Or is it the VOR and VHF? Okay, remember I mentioned radio management panel. It's your RMP and ACP. All right, next question. The communication system on the Airbus A320 is only for communication between the pilots and everyone on board the aircraft. Is that true or false? Okay, it's false. Remember I mentioned about ground service personnel, like you guys. Also ground from the, anybody at ground, also radio navigation. Okay, so we're talking about ground stations as well. All right, what kinds of speech communications are there? Okay, so your option 1, low frequency system and high frequency system, or very high frequency system and high frequency system. Okay, remember I emphasized that. It's very, it was high frequency and very high frequency. Okay, so what is the function of the radio management panel? Is it to, number 1, create a centralized control of the data communication systems, or to create a centralized control of the radio communication systems? Okay, it's B. It's B. It's the radio. All right. The ACP audio control, ACP, which is the audio control panel, serves as a backup for the flight computers. Okay, is that true or false? Okay, it's false. I mean, specifically, I'm talking about the radio management panel. That is specifically a backup for the flight computers, flight guidance. Okay, so how many transmission channels are there on the audio control panel? You can just sort of toss this question out. There are actually 7, but again, I didn't want to hold you to any kind of quantity of them on there. Just know that there are several transmission channels. Okay. All right, and the other question is, remember, which one's for short range, which one's for long range? Okay, so if I ask you for what kind of transmission is the high frequency system used? Is it short range or long range? Okay, it's long range. Okay, I'll just go over a few others. I got a lot of them, but we won't go over them right now. All of them anyway. All right, so the DEUs type B are connected to what? Okay, you have 2 choices. Emergency power supply units or the directors. Okay, well, it's specifically I was talking about safety equipment, and emergency power supply units are part of safety equipment, so that's the answer, is that one. All right, okay, let's see. Okay, we don't have to get. Okay, that pretty much gives you an idea of the different questions that can be asked, and we're going to have a review of all of this, and so we'll bring in. We're hoping to have availability of our aircraft mechanic, who's part of OA. That way, he can kind of give you some tips, etc. And also Rick, who's our aircraft pilot. He's also a flight instructor, who also is, I mean, he talks extensively to the aircraft mechanics and has a few little tips, I should say, as you can, consider. Okay, we're not saying this is an AMM thing, but it's certainly something that has worked. But just for information, that's all that's for. Okay, all right, so this concludes our topic on communications for the Airbus A320 family. Certainly, if you have any specific questions that you got maybe inspired to think about while going through this course, please feel free to email us with those questions, and we'd be more than happy to answer those.